Alright, in this video we're going to be looking at exercises where we're using the normal distribution and finding a raw score. Okay, so in these problems we're going to be given actual values for a data set and then asked to imagine that we used a standard normal distribution to solve for certain values. And so part of these problems, or a key component of these problems, is going to be finding a z-score sort of as an intermediate step to locating a raw score. Okay, so let's start on this question. So it says, suppose quarterly sales levels among healthcare information systems companies are normally distributed with a mean of $12 million and a particular standard deviation. One healthcare information systems company considers a failure if its sales that quarter is in the bottom 20% of all quarterly sales levels. Determine the sales levels, that's the cutoff, between the quarters that are considered failure and the quarters that are not. Okay, so let's go ahead and I like to just visualize this first right away. This helps me kind of see what the problem is asking. Again, here's my terribly drawn normal distribution. In the center of a standard distribution, we would have 0 as the mean, but we're working with actual values here, so we know from the problem that this mean is 12 million, and I'll just leave the million off. And we also know that the standard deviation is 1.2 million. Okay, and so now we're trying to decide where is a failure. Okay, so a failure would be the point at which I'm in the bottom 20%. And so we always are working to understand the distribution to the right of our value, though. We saw this when working in the standard normal distribution as well. And so basically this portion of the distribution over here to the right of this line represents 80% of the distribution. Okay, and so we're going to, instead of working with the 20% that's given to us in the problem, it's easier to work with the values if we're working with the area to the right. So we're going to go ahead and use 0.8 instead of 0.2. Okay, and so basically what we're looking for in this particular problem is a value of x such that it's greater than our little x value right here that represents our cutoff. And this is equal to 80%. And the formula that you want to use here is actually x minus mu, right? This is mu over here, 12 million, divided by the standard deviation. And as I mentioned, we're going to need to find a z value as an intermediate step. And so we can just write that in here. Okay, and so our formula works out to be x minus 12 million divided by 1.2 million is equal to z of 0.80. Now, the reason I'm leaving million off is because in the question it says determine the sales level in millions of dollars. Okay, so we're not going to have to write in millions over here. We're just going to need this simplified version of it. Okay, so we want to first go to the calculator and find what the z value at 0.8 is. And we find that that z value, 0.8, is equal to negative 0.8416. And this is equal to x minus r mu, which again is 12, divided by a standard deviation of 1.2. And so now we just want to solve for x, so we're going to multiply this negative 0.8416 by 1.2. And so we have negative 1.0099 is equal to x minus 12. And then we're just going to add 12 to the other side to solve for x, plus 12 The nice thing about the calculator in ALEKS is you can just leave it all there and do each step as you go, so you don't have to like transpose or make an error rewriting the numbers. And so in this case, we have x equals 10.99. And so again, just sort of revisualizing this, our mean is 12, and our standard deviations are 1.2. So at one standard deviation, you're right at about 9.8, and you would keep going down. And so what this tells us is that when x is equal to 10.99, 80% of the distribution is to the right, and 20% would be to the left. Okay, so we'll just go ahead here, and it asks for us to use to one decimal place, so we'll say 11. Right, so 10.99 is going to round to 11.0. And that's correct. Okay, so let's work on another problem from this section. In this problem, risk-taking is an important part of investing. In order to make suitable investment decisions on behalf of their customers, portfolio managers give a questionnaire to new customers to measure their desire to take financial risks. The score on the questionnaire is approximately normally distributed. Okay, and so again, we have sort of our important information here for the problem, which is that we have a mean of 50 and a standard deviation of 14. And it says the customers with scores in the bottom 15% are described as risk averse. So what is the questionnaire score that separates customers who are considered risk averse from those who are not? Okay, and so really similar to the last question that we just did. We have some cutoff where this represents the bottom 15%. Okay, and so what that's going to leave us with is the top, if you will, 85%. Okay, and note that this cutoff value, whether we're working towards a lower 15 or an upper 85, is exactly the same. But when we work with these probabilities, it's always the probability that the area under the curve is to the right of the cutoff. So again, we're going to work with this 0.85. Okay, and so z of 0.85 is equal to x minus the mean, which is 50, divided by the standard deviation of 14. And so we've got to go over here and get our z value from the calculator. So negative 1.0364 is equal to x minus 50 over 14. And then we want to multiply the left side of the equation by 14. Okay, and then we want to add 50 to the left side of the equation. And that will be our answer. And again, we're looking for one decimal place. So 35.5. Okay, and so I want to do one more question with you because so far you've seen two pretty identical questions. And so here what we have is, suppose that scores on a particular test are normally distributed with a mean of 110 and a standard deviation of 19. Okay, so we have a mean of 110, standard deviation of 19. What is the minimum score needed to be in the top 5% of the scores on the test? So we have some score x, where the area to the right of the curve represents the top 5%. Okay, and so this is actually a little bit more straightforward than the problem we just worked on. And so x minus 110 over 19 is equal to, and when I say it's easier, it's just because this area is already to the right, so we don't have to think about, do I use 0.05 or do I use 0.95? So we'll go to the calculator to get the z value for 0.05. So we have 1.6449 is equal to x minus 110 over 19. Right, so we're going to multiply the left side of the equation by 19. That gives us 31.2522 is equal to x minus 110. So then we just add 110 to the other side to solve for x. Okay, and it asks for one decimal place in the answer again, so 141.3.